Hello, everyone. Good morning. Thank you all for your attendance, both here on site and online. I hope everything's fine with the online session, that you can hear as well and see as well. And do you want to say something, Aleida?
No. Okay. Just to say welcome to everybody. Also people online, people on site. We will start with the Spanish workshop of eFORT project, prepared together with ESTELAR project. So as you may have seen in the agenda, we will start presenting to all of you the eFORT project and what we have done and what could be interesting for all of you, mainly for the external stakeholders. The same with ESTELAR project, and then we will deep dive a little in the Spanish, in the specific case of the Spanish demo site. And afterwards, we will have hopefully interesting panel session where different external experts will discuss about the technologies developed within Spanish demo site, but in real field. Okay, so yeah, that's all from my side. I am looking into the chat, so if you have any issue or anything or any question, please include it in the question and answer bottom. Yeah, that's all from my side.
Thank you.
The floor is yours.
Thank you, Aleida. So now, with no further ado, let's go with our session. I will go directly to the agenda to have a first look to what we can expect from today's workshop. As you know, this is a workshop belonging to eFORT projects. And given that we are celebrating our General Assembly here in Granada, the location of one of our demo sites, the Spanish demo site, from now on, we will focus our workshop in such a demo. eFORT has a wide coverage of the power systems. It's a project focused on resilience and cybersecurity of the power system. We will see an introduction now. And given that covering as much as possible of the power system, this demo site is focused on distribution grids, and particularly from high voltage, medium voltage distribution grid downwards, so that medium, low voltage grid. We find it very interesting and useful to set our workshop in the energy communities domain. Cuerva, our hosting partner today, responsible for the demo sites, presents a very valuable living lab in these voltage levels, joining together several distributed energy resources, empowering energy communities. So for us, it's a very interesting topic to cover today, and as we are saying, keep on the overall view of the power system that it provides. In short, we will go back to the title of today's session. We will see how deploying and enhancing cybersecurity all over the power system, and particularly on energy communities, improves our services, the services that can be provided to the grid, and the implications that cybersecurity developments have for developing our technology, our system, and our services. So, in the plan for today, we have the welcome and introduction that is going on as you listen us, where we will see this overview of eFORT project and also the ESTELAR project. We wanted to take the opportunity to also introduce this second project, which is another project coordinated by us, by CIRCE, and which shares, among other things, the collaboration between CIRCE and Cuerva, hosting several demo sites. We also share other partners, as we will see in the introduction. They are both very technology-oriented projects, as we will see, and very digital-oriented projects. And we will have the opportunity to explore a bit further the synergies and common foundations of the technology of these projects in order to look for these more secure, advanced, digital, and resilience grids. After that, we will have a brief presentation of the Spanish demo, the main topic of today's session, by Ángel Gómez in representation of Huelva as host of the demo site, and then a panel session with 3 presentations focused on, as we were saying, in energy communities, cybersecurity, and digital domains. I will not stand further now because we will have this specific session and presentations moderated by Gregorio López, our colleague and partner of this project from Comillas University. After that, we will have room, hopefully, for Q&A. We will try to push the debate here with partners' questions, and also more important even, questions from the attendants, the Q&A box, the tools from the meetings, from the Teams meeting are open, and we expect you to contribute us and share your impression. And finally, a last short interval for wrap up and conclusion. So this is another view of the demo sites, and let's go with the introduction of these 2 projects, eFORT and ESTELAR. From my side, I leave my introduction at the end, sorry. I am Jesus Torres, I work for CIFE, I'm in charge there of the Digital Transformation Group, and I take part of the eFORT coordination project teams along with my colleagues Aleida and Esteban, and today I will be introducing this project. So, as for eFORT, as you can see, quite a relevant project for an Horizon Europe call, given that we are talking about a 4-year project, €1 million budget, and more or less around 20 partners covering a wide, representative geographical area within Europe. You know, we have northern countries, Central Europe well represented, the eastern part with our demo in Ukraine, and Mediterranean areas hosting several demo sites, such as the one in Italy and Spain. We will see the details later. That's a very comprehensive and complete consortium, given that all the value chain is represented there. We have utilities, we have technology providers, we have technology centers, research, academia, and consulting firms. As for the goals, let me show that all together. I like to summarize that, as I said, that this is a very solution-oriented, very technology-oriented project with a clear baseline that goes from technology development, as we will see in a minute, technology development, very digital-oriented, enabling advanced strategies and operations for state-of-the-art management of our assets of several domains of the power system. So our baseline, as I was saying, could be summarized as a comprehensive analysis on vulnerabilities landscape, along with risk qualifications, virtualization tools, definitions of secure frameworks for data exchange based on that landscape of vulnerabilities and risks, and then technology development, as we are saying. Technology development focus on several tools and resources that are combined into strategies, operational setups, and algorithms for a secure advanced operation. We will have the opportunity to see that. That being said, our solutions and technologies are demonstrated in 4 demo sites that we will see right away. This is a visual summary of what we are explaining. If we go from the bottom up, we may start by summarizing the digital technology, several state-of-the-art digital applications examples relevant there, such as the development of operational protocol-based intrusion detection systems, the integration and deployment of end-to-end security-based systems, digital twins for the whole power grid domains, blockchain developments for secure data traceability and access, AI-based control algorithms, and all of that executed and related to edge computing and IoT. The usage of these and similar technologies lead us to, as we are saying, advanced strategies such as cascading effects study and management, security SODSO data sharing, islanding operation, IoT impact, the impact of IoT-related attacks on our grid, secure box for real-time monitoring. Secure box is an edge device for real-time data acquisition and monitoring and intrusion detection system. Very relevant environments such as the one of our demos and the control room of the future. These are all showcased in our demo sites, which are the 4 sites that you can see there. The first one is focused at DSO level, as we were saying before, from high voltage, medium voltage substation downwards, and is located here in Granada, hosted by Cuerva. Next, we have the Dutch demo site hosted by TU Delft and oriented by the very state-of-the-art facility of the control room of the future. We have at a scale replica of a control room demonstrating advanced operation, new algorithms, AI-based recovery and operation of the grid, and secure demonstration at a scale for showcasing and training. Salentino Valley in Italy hosts another demo site, which is new tools based on digital operation, digital interfaces, and AI-supported operation and control strategies for DSO networks as well, dealing with islanding operation and generation control. And last, our demo site in Ukraine, in Ilsi, next to the western border of the country, where we have a full substation at our disposal to explore secure design and secure data access over this kind of facility. The diagram in the upper side just want to show that given that we have a lot of technologies, a lot of strategies and algorithms, we conducted a comprehensive analysis about what to demonstrate, what to apply on each demo, a really end-user-oriented demo site analysis, so that maximum added value can be provided to our utilities and our end clients looking for replicability and impact of our solutions. So let's go for a quick view of about what we are developing and how we are applying that. And first, before getting a brief summary of each demo site, we have here an example of several cross-cutting developments or project-wide development that were carried out during the first stages of the project. For example, as we were saying, we have vulnerabilities analysis and database. I think that it is a very interesting result because it includes a very comprehensive rehearsal and research activities combining several relevant sources and a very detailed analysis of the vulnerabilities, mapping them to asset and risk specific to the assets, and obtaining a score and a criticality assessment of each vulnerabilities directly mapped to the power system, and providing a result which is very practical and very related to the daily operation. Along with that, we developed a visualization dashboard with interesting tools such as hypothesis tool that let us introduce or customize our assets of the grid, select relevant vulnerabilities, and work with dynamic scenarios, assessing the situation of our infrastructure. Another project-wise or initial study which was interesting and leading also to scientific publications was the IoT-based cybersecurity vulnerability basis. We demonstrated in the project how compromising IoT devices, distributed devices of the power system, such as electrical vehicle chargers, can meaningfully impact on the whole power system, and also how strategic actions such as integrating distributed generation, solar photovoltaics in this case, contributed to a more resilient behavior of the grid, which is a really interesting end-to-end and combined approach for problem and solutions. All that combined with a dynamic risk assessment tool integrating cyber layer and physical layers with this cyber physical approach. Another interesting project level development is the intelligent platform. It was an interesting domain because it let us see during these years the evolutions of digitalization, data sharing, and exchange in these domains. We are moving from resource-intensive, centralized data integrating platforms to a lighter data exchange approach, such as digital spaces today. And we again perform a very comprehensive initial analysis to explore what we will execute around this platform, what data we will be sharing, so that this is a very optimized approach that combines application execution and data sharing and common visualization. I think that with this intelligent platform, we showcase the whole value chain. We showcase the alternatives between data centralization and a more oriented collaboration focus on dynamic data exchange and application execution. And we have very replicable approaches and strategies for connection, data exchange, and application execution. Going now through the demo sites and leaving the Spanish one for the end and for the rest of the session, let me very briefly share the main developments that are hosted by each demo site. In the Netherlands, we have the control room of the future that is, as I said before, a scale control room facility, which is mainly focused on executing and demonstrating advanced detection and recovery strategies based on AI, and as a training facility for operators to replicate new processes and strategies. We have integrated there advanced algorithms, as we were saying, for oscillation detection, cascading failure management, evolution and optimization of islanding and reconnection recovery strategies, all of them integrating deep learning and cyber physical approaches, and a complete full security operations tool suite or control system that will be used to showcase our activities in the final event, boosting some demonstrations based even in real-time red teaming and blue teaming actions, or as we are saying, relevant emulation of real conditions or real potential cases regarding resilience of the power grid at a TSO level. As for the Italian demo sites, it is focused again on distribution level. We have used the models of a complete distribution area of a DSO, Edina, in the Salentino Valley in Italy, and we have developed several interesting digital operation tools. We have the Smart Grid Controller, which exploits existing digital information to acquire information and enable a parallel plane, a parallel tool for operators to get more advanced and visual interfaces for grid operation and obtain AI-based recommendations, moving on with this new paradigm of human-in-the-loop assisted operation and new recommendations for advanced insight on our grid. Of course, the control responsibility and power still lays on the human operator, but we have this new full set of new capabilities and visibilities. And here we also set the focus on islanding operations. So we have a very interesting development in terms of reinforcement learning and short-term forecasting applied to the operation in islanding mode of this grid segment of distribution grids in sometimes difficult geographical environments, such as this kind of rural mountainous area. And we also integrated a chatbot, also supported by AI, an interesting application, I must say, of exploiting the systems of digital information. Because at the end, if we do not use digital data that now is produced and shared among our power systems for this kind of new applications, the digitalization may still remain as a new generation of traditional control and automation operations. As for our Ukrainian demo sites, it's again centered on a substation, distribution level substation, and we have carried out there a complete end-to-end secure design approach to a substation project. Starting from on-site scanning to obtain a full high-resolution point cloud of the substation, we obtained very detailed and realistic 3D models that can be used to be accessed either on digital interfaces or augmented reality interfaces, and can be used to ask for training, monitoring, maintenance, and diagnosis of our facility. In addition, we integrated that models with digital data related to the design of the facility in a secure way, both with BIM projects and blockchain-based information. That way, we wanted our substation design to be linked to new procedures and to centralize and store the information in a secure, accessible, fruitful way. We have developed there a parallel living lab in a control room next to the switchyard of the substation, where we are demonstrating our end-to-end control architecture with remote terminal units from Schneider, a secure box with IDS, and a whole substation automation system focused on detection of cybersecurity events. As for last and most important today, we have the demo site. I will not stand here because the rest of the session is centered in this demo site, but as I was saying, we have a medium low voltage grid section along with the substation and focus on distributed energy resources, and also operational traffic analysis for intrusion detection system and cybersecurity algorithms. And that's all from eFORT side. And before moving on, let me very quickly go through our companion project today, which is ESTELAR. I think the presentation is being shared now, so quick pause and let us move to this other project. ESTELAR, as I was saying, is also coordinated by CIRCE, and we will share and we will see how the technology and developments can be connected with eFORT and this new ecosystem of digital power grids. As for the project overview, I lost my control here. It was frozen, sorry. Okay. Let me reopen that. Sorry about that. Okay, so ESTELAR project again, really digital oriented, really technology oriented, but with a narrower scope than eFORT. This is a project that wants to explore and verify fundamental technologies needed for a secure, reliable, and productive development of virtualization technologies. In a very quick note, virtualization in power system means that if once we proceed with power system digitalization, and the more digital data we have on our system, the more we could rely on software-based applications, because if every measurement, every control command, every signal is exchanged via digital way, we could progressively reduce the hardware, the physical hardware components of our system, and move towards software-based systems. This new approach, and specifically in critical infrastructure such as the power system, requires to maintain or even enhance the reliability, performance, and operational features and characteristics of our automation systems. So we need enabling technologies and verification means for that. So this is the main objective of the ESTELAR project, is to advance virtualization technologies for the digital substation of the future via these enabling technologies for a secure deployment. Which are the main verticals or pillars of these technologies? We have them here. Revised communication strategies. We need reliable, trustable communication, fast for data exchange. Indeed, for these software-based systems, we need advanced computational and emulation frameworks to study the different software architectures that can comply with the time-sensitive requirements of these applications. We need to explore how new generation substation automation system and VPAC architectures are integrated and operated, and all of that with two state-of-the-art technology laboratories, interconnected to validate our conclusions. This presentation is my enemy today. I don't know what it keeps freaking. Sorry about that. I will open that in the Explorer just to see if it works better. Okay, so within that context, there were some specific needs that we thought they need to be addressed, and they are very related to the vertical, to the pillars we presented: the communication, secure, reliable, fast communication, different software architectures to study how they comply on they are reliable and consistent and real-time compatible. That's the robust computing and emulation strategies, and the new architecture for a scale one-to-one virtual substation automation system or virtual protection and control system, integrating not only these technologies and the substation operation, but also, again, advanced cybersecurity technology. This is the main figures of the project. As you can see, Cuerva, TUDELF, and CIRCE are shared partners in this project. This is a narrower one, as we were saying, 3-year and 3 million budget, and these 9 partners for our objectives that are presented here. The 3 first one are very related to the technology we are discussing, so it is worth mentioning in more detail the 4th and 5th ones. The demo sites of this project are laboratory-oriented and testing-oriented, and we have CIRCE and TUDELF laboratories, digital substation of the future, that will be interconnected for a joint validation and impact assessment. We think this project can be very scalable and very replicable because we are focusing on what virtualization software basis needs for a proper performance. So our conclusions and our methodologies will be of use for a lot of domains of the power system, along, for, of course, with our dissemination activities. This is the work package structure. It is very related to the digital technologies, but I will not extend further. The 3 pillars we are mentioning: the communication, the computation, and the digital substation of the future. The project has been through its almost its first period. We are at month 15, if I'm correct, something like that. And we have achieved several developments and milestones that are summarized here. We are with a practical approach characterizing several communication technologies with the actual facilities of the demo site of Cuerva, of its substation and communication network. And we have already published 2 papers, one of them centered of the practical activities measuring and demonstrating alternatives with measurable delay as alternative communication channels, and also compatibility and calibration of standalone merging units, which are really important in these virtual substation automation domains, since they are the source, the main input data source, because they provide the digitalized and sampled measurements of our system, as you already know. Voltage and current measurements are the base for the protection of the grid. We have already advanced in data sets and behavior of real-time system, demonstrating in practical setups of virtual IDs. As for the virtual protection and control complete architecture demonstration in Delft, we are working on a tool for cyber attack detection, cybersecurity, concocted data sets from operational data, 6150 data, and creation and evaluation of intrusion prevention system, not only detection, but moving on to prevention. This is the impact, your typical impact. I will not stand here, only to mention again that we are convinced of the potential of replication and impact of these projects about being that basic technologies for the new trend in digital operation of our grid. As for the deployments, we have, for the laboratory, and the demonstration part of the project, we have the digital substation of the future facility at TU Delft. I will say a complementary or closing the circle with the control room of the future. We have at a scale digital substation with a lot of market-ready virtual protection and control resources integrated in a complete virtual substation automation system with IDs, merging units, communication, local area networks, and a complete environment for demonstrating everything. Also supported by RTDS simulation. We have here a picture of the control room of the future, so that we have there as well a complete view of the transmission, high voltage and distribution systems. In CICE, we have a laboratory more centered on the fine grain of the application in a complete setup to completely develop, test, and measure our applications. And I will not go into detail of all the components that are listed here, but they are listed to showcase how these new environments require a lot of new tools and new resources. And as we were saying, Cuerva facilities and Cuerva Living Lab and Demo Site are supporting activities of this project, such as the communication characterization. So just to end up, I hope you find interesting the relationship between these two projects, and as we were saying, at the end, they all belong to this domain of automation, extended digitalization, and software-based digital systems. As we said before, as digitalization increases, we need to use this digital data to develop new applications, obtain a more resilient and more advanced operation of our grid, and making the most of our systems in a more efficient and hopefully with less resources way, integrating a new generation technologies. This is, after all, new paradigms that we are trying to showcase, demonstrate, and validate and produce results about for new paradigms for development, testing, deployment, and maintenance of digital power systems. Apart from my contact details that are in both presentations, here you have the details for the project coordinator, ESTELAR, in case you need to address to us or contact in any sense. So have the agenda here, and before moving on to the presentation, we have now the presentation of the Spanish demo by Ángel Gómez, representing Cuerva as demo host, and then we will move to our panelist, and moderated by Gregorio López, as I said before. Thank you, everyone, and let's focus on the Spanish demo side. Thank you.
Well, thank you for the presentation. Hello, good morning, all. My name is Ángel Gómez. I'm going to share with you what we have been doing in eFORT in the demo one, the Spanish demo. As Jesus has said, I'm from Huelva, and we are the leader of this demo. This is the agenda. In this demo, we are working with PIRCE, with Universidad de Comillas, with SNAIL and CIAF, and we are developing some tools about the IoT, the blockchain, and the cybersecurity in a major way. I delay the presentation of Huelva, but Jesus has done it. We have a low voltage grid that we are using in this project, and we have three key components on this Spanish pilot. The first one is about cybersecurity and the blockchain with battery information exchange. We use the information about some batteries that we have in our grid, and we are testing how we can use the blockchain to exchange information between them. The second important point is about the secure box. It has an EDS, and we connect it to an intelligent platform that we have developed in the project. The point here is that we use it to monitor design or telecommunication grid to know if we have some problems, some cyber attack from outside of our grid. And the third one is about the cyber attack analysis in digitalized low voltage network. Here we have a screenshot about the Fornes community network. We will talk about that after this presentation. But all these three key components have the same important point, and is that we need to have a secure communication between all the components that we have in the grid to allow us to ensure that this grid is going to work properly. For the blockchain that we need to share all the information properly, a VPN channel, a second VPN channel that provide the encrypted tunnels required to check all this information. About the second one, the secure box, the most important thing in that point is that we need a resilient routing protocol to share the information between the substation and, in this case, the intelligent platform, to ensure that all this data is not going to be denied. Or we use a protocol named PUS to know some information about if we are being attacked or not. In the third tools, the most important thing is to establish the network baseline to know if we are going to control all the devices that we have in our grid properly. All this thing that I was talking about is the thing that we are studying in ESTELAR. We are developing how to increase the VPN channel. We have made deep research about how we can connect all the devices to our grid, because in some place we are going to have 5G, for example, here in the city town. But we saw yesterday that not all the substations are in the middle of the city. Maybe you can have some points on the middle of a village or in other place. So we need to show which technology can help us to connect to this point. And well, that's we are doing there in ESTELAR. Not only this, but very soon. Well, there we have the schedule of the eFORT project. We are in the last 6 months of the project. We are finalizing all this installation and all this testing. And now I want to focus on the risk analysis tools that we are doing with Comillas. At this point, this tool is used for simulate network attacks, and it uses statistics to model attacks on multiple network nodes with different forward levels. It's developed by Comillas, and it has been adapted to use it in a medium and low voltage network. Well, why it's important today? Because the resilient scaling is the network. Well, we have made several tests with these tools, and we have seen 3 important use cases. The first one is if you have your network totally scaled, you are not going to be a problem if they attack the load capacity. Only they increase the load capacity. The second use case is, well, maybe you don't have this network properly scaled, and you are going to have a problem. But it's physical problem because you can change the fusion, you can change the transformer, you can adapt the line, so you can solve it. The real problem here is that maybe they can attack the maximum consumed power, the peak load of the consumer, and after that attack the consumption of these loads. So they increase the power that they are able to consume, and after that they increase their consumption. There you are going to have several problems. We are here to demonstrate that cyber attacks aren't just IT issues, it's real and physical issues too, and has a consequence on the grid. Or tool, or these tools allow us to know about this problem. Why we are here? Why are we going to talk about community, energy community, and flexibility? Because in this energy community, we have several inputs, several loads, digitalized that could be an entry point for the cyber attacks. And flexibility will allow us to solve this problem. Yeah, so finalize. In this section, we will explore the definition of energy community, identify which device is more vulnerable to potential attacks, and demonstrate how flexibility serves as a vital tool to integrate this risk. That's all from my side. Thank you so much. And I think that everybody can continue with the presentation.
Hello, thank you very much, Angel. Can you hear me remotely? Is everything okay? Okay, good morning, everybody, and welcome to this Spanish workshop titled How Enhancing Grid Cybersecurity Impacts on Energy Communities in the Spanish Demo. Let me introduce myself first. I'm Grego Lopez. I work as Associate Professor at ICAI, the Engineering School of Universidad Pontificia de Comillas, but I also serve as coordinator of the Cybersecurity Microscience. My background is in telecommunications engineering. I have been researching for more than 10 years. I started researching in wireless access networks. Then I moved to machine-to-machine communications, Internet of Things, and since 2019, my main research topics are related with cybersecurity. More precisely, I work in cybersecurity and IoT, OT, critical infrastructures, also in the intersection between cybersecurity and artificial intelligence. And we also have an active research line related with the use of serious games, both for prevention and research in cybersecurity. As a part of the eFORT project, as you guys know, we have mainly contributed to the analysis of IoT, high voltage IoT devices vulnerabilities, and also the evaluation of the impact of compromising and remote controlling these kinds of devices on the electrical grid. So once I have introduced myself, let me remind you how the workshop organized. So first, we have 1 hour, 3 presentations, so more than 20 minutes presentation. If you have any question, I would kindly ask you to write it down, because after this 1 hour that we have for the presentation, we have 30 minutes for question and answer. Let's start with the first presentation, which is going to be delivered by Cristina Garcia. Cristina Garcia is an industrial electronic and automation engineer from the University of Granada and the University of hope I pronounce it properly. Master degree in Internet of Things. Since she joins Huelva in 2023 as an R&D project manager, she has been involved in European innovation projects focused on digitalization and smart grids, energy communities, and smart buildings. With a strong technical background in renewable energies, she brings expertise in the integration of distributed energy resources and communication networks, combining project coordination responsibility with technical insight to support the development and implementation of advanced energy solutions. Cristina will discuss a real-world energy community, highlighting the ongoing developments within the projects and the tangible value it delivers. So, whenever you want, Cristina, the floor is yours.
Thank you, first of all. Well, I'm Cristina Garcia from Cueva, and I'm gonna present the first panel. It's about the user at the center of the energy community. So we are right now here. We are not good on time, but I'm gonna be short. So here you can see our project is focused in a small rural area called Fornes. So we have built an energy community there. As I said before, it's a rural village with 500 inhabitants, so it's very small town. And we have a big community demand of 250 kilowatts and over 340 total supply points there. The challenge here is the user, because the user profile is a very old elderly people, so they don't really use technology in their life. Here I put the architecture of our system, of our pilot or a small living lab in the Fornes town. So here you can see 5 layers. The first one is the physical layer where all the devices are installed. The second one is the edge processing layer. The third one, I'm gonna talk about machine learning models implemented in our demo. And then I'm gonna brief talk about markets and the users at the end. So the most important part in this presentation is the application, is the last one, is according the user experience and the community. So at first, the first layer, as I said before, is the physical layer. We have a PV installation in the town hall of the village, and we have 2 pathways. The first one is for private users. So there are 25 houses that take this energy, And the second one is the public pathway. We don't have just houses in our community. We also have a public building such as the school, the medical center, the nursery, the sports center, a swimming pool, and also the theater. So the PV generation is shared in all of these users and buildings. Also, we have some assets, a battery for store the generation, the surplus energy, two EV chargers, also located in the town hall. We have installed smart meters in the houses of the private users, so we can monitor the consumption in real time. And also, we have installed an RTU in the grid in our secondary substation to monitor all the power, the current, and all these measurements. At the end, I'm gonna talk, well, right now I'm gonna talk about our IoT system. That is installed in the public buildings, and it's composed for smart meters, smart switches, temperature sensors, humidity sensors. We are monitoring some variables, this measurement, for control the air conditioning system in the public buildings. Now we are going to move to the second layer. As I said before, is the edge layer. So we have installed Node Edge based on a single board computer from Advantage in the town hall. This device acts as a gateway. It has installed the Barbara operating system with remote over-the-air vulnerability patching for improve the updates of the devices. It has an encrypted tunnel and some controls implemented to avoid cybersecurity attacks. Also, this device is preventing the cloud overflow and reducing the latency. Also, we have implemented a blockchain system in this device. It's a traceability system that proves and that all the energy that where the energy comes from. I mean, if it's from the PV, the battery, or the grid. The third layer is the data processing and machine learning analytics. We don't have just a data collection process. We also have improved some algorithms such as generation and consumption forecasting to anticipate the future and anticipate the residential consumption with the historical data and the real-time data that we have collected before with the smart meters, and also anticipate the renewable energy yield from the PV. So you can see here 3 graphics. For example, this one is from one user. So you can see it's quite complex to forecast the consumption because depend on the habits on the user. But you can see here the circle is the true measure and the other form is the prediction. The fourth layer is regarding markets. So here we have the results of the result of this system in terms of markets. So the idea was to implement it all of these markets, but we have some challenges here because, for example, peer-to-peer is not allowed in Spain. So we wanted to prove this kind of traspasar. Well, we wanted to prove this market, but it's not allowed in Spain. The first one is demand response that we are doing here in Fornes. So the users can reduce their electricity bills during the peak response. Also, we are trying to prove the flexibility markets. So the idea is that the users and also the community can provide flexibility to the grid. How? With the battery, with the adjusting of the air conditioning system, and trying to give more flexibility to the grid from our resources and our assets. And the last one is quite with a small TRL. So it's using the blockchain-based traceability to origin a new market with this certification of energy. So right now we are in the last layer. This layer is where the users are in the middle. So all this system is useful for the users, so they can be comfort in their building, because we have changed and build the system for improve their indoor comfort with the actuators that we have installed. So there will be comfort, and it's not a manual, it's automatic system. So that's the first application. The second one is about improve the knowledge of the energy and the decision making. As I said at the first of the presentation, the users are very old people, so they don't really know how to use the energy. They don't really know about their habits. So the idea of this project is also to improve this knowledge. So we have made some smartphone application where they can watch their consumption, their habits, and with some recommendation. Also, we have developed a NILM system where the consumption is disaggregated at device level. That means the user can know if their fridge is consuming more than the washing machine, or if there is a problem in one of their devices in their houses. Also, an important part is the reducing the electricity bill and the cost minimization. So with this optimization system, the battery management strategies and the demand response optimization, they are gonna save money. So that's the most important for the users. Then we have the energy efficiency and optimization. This one is based on the reduction of CO2 emissions, and the idea is to be a very local, rural town, but very sustainable and at the front of the energy of Europe, for example. And the last one is the energy transparency. So the blockchain-based, with the blockchain-based energy traceability, the real-time monitoring of energy origin, and the verification of energy distribution. So what problem does it solve? At first, the inefficiency energy consumption, the limited support for informed energy decision making, the limited integration of renewable energy, the low user engagement in energy management, the lack of transparency in this energy community system, and the awareness of energy consumption, the electricity use and the habits. So you can see the flow. We generate energy, we measure with IoT system, we implement a secure box with this node edge, reducing the latency. We optimize all the data that we are collecting with forecasting and other algorithms, and we have all these benefits for the user. So that's all for my part. Do you have any question?
Thank you so much, Cristina. Very interesting presentation. So if you have questions, we can address them by the end of the session. We have 30 minutes for that. So the next presentation is going to be delivered by Nazaret Garcia. Nazaret Garcia is the user experience lead at Verdi, where she actively participated in several current projects. I work with the component energy community for spaces where sustainable energy management and more existing. Her presentation will provide us with a specialized vision on how an energy community is created and the specific value it delivers to its members. So whenever you want, Nazaret, the floor is yours.
Thank you. Okay. Lo voy a poner en grande. Well, it's okay like that, or we can try to. Well, it's okay like that. You can see it correctly. Yeah.
See, as you see that.
Okay. Well, I'm working for Verdi, and my name is Nazareth. Nice to meet you. I'm happy to be here, and thanks so much for inviting me to the workshop. Verdi is that we do is promote communities that provide people needs, or as we say, solar energy, whether you have a roof or not. We have a targeted product. We work from the most technical aspect to the most social. First of all, we work in the community design. After we work in the installation and the setup, and also we cover all the setup support and guidance in the end of the projects. We are working and we are fighting for trying to move from an individual model to a collaborative model in which the user can have open participation, voluntary participation. Also, we need citizens awareness and development of local environments. So how it works is energy community or Verdi energy communities. We install the solar panels on a private rooftop, for example, in a school or in a company. After we divide the installed capacity into 0.5 kilowatts package, we call it Verdi panels, and which people within a 2 kilometers radius can rent or buy according to their needs. We also advise them what number of Verdi panels they need. We can study the consumption. Verdi also is the responsible for ensuring the optimal performance of the installation. We do all the onboarding and offboarding of the member billing, and provide service to the users. About the technology that we use for trying to scale this business model, we have a Verdi customer area that in the end is designed to give to the user full control over their energy in a simple, accessible, and transparent way. Some of the functionalities that the Verdi area have is tracking the energy community status from the syncing to the activation of the user. Also, we have personalized assistance in the real time. Check the energy at any time, so the consumption and the production monitoring. Also, the users can watch the impact and saving generated, viewing the accumulated impact and saving, including by period. some automation of basic process, like, for example, back account chains, account holder chains, and other operation. And access to the invoice and contracts, trying to be fast and secure documentation. Also, we are working on a marketplace. Now we are working on it, so I don't have so much information because it's on project. But the idea is have a simple way to buy and sell the solar panels, or we can say the Airbnb of the energy, like for idea. But we are working on this now. And for sure, we have also all the installation, control, and management of the consumption in one software that is that very manage the access to the maximize its performance, so they don't have to worry about anything. Some of the functionality have for the member management and support, for example, the consumer billing or the management of allocation coefficient, or also the member management and support. For sure, the operation and maintenance for monitoring and supervision, and also for do the preventive maintenance and the corrective maintenance, all in one application. With all this, we can say that we reach some numbers, good numbers in this year. We have two on service. That is 19 energy communities on service and more than 600 member participants. And now we are following to doing some energy community with 107 kilowatts in construction. That is, thank you.
Thank you very much, Rafael. So let's move on to the next presentation, which is going to be delivered by Pablo Blázquez. Pablo Blázquez participated in the eFORT project indeed.
Yes.
He was working in the project at the beginning, right?
Yeah.
Pablo joined Cuerva in early 2022 for the innovation department, participating in the proposal and execution of national and international R&D projects related to smart grids. In 2025, she is a smart grid senior consultant at Digitalisation. Digitalisation is a spin-off of Cuerva, where he currently works on proposing various projects to focus on flexibility and defining the market necessary in large-scale deployment. Pablo will discuss how flexibility enables the grid to be stabilized by leveraging its own distributed assets. So whatever you want, Pablo.
Yeah, so thank you. I don't have any to add to the presentation. So yeah, and now I'm working on Gridify as a consultant for other DSOs in how they can improve the visibility on the grid, and also how they can integrate new technologies and participate in new markets at technology and regulatory level. But I mean, I try to focus on, in the last part, to focus on the cybersecurity level of all of these local flexibility markets, energy communities, and so on. I'm not an expert, but if you have any question, you want to comment anything, any point, you can interrupt me. So first of all, I want to mention 3 key points for me in this energy system transformation. The first of all is the decentralization. So we see in the last years a rapid deployment of distributed energy resources, not only at energy community levels, also DSOs and system operators are starting to integrate, for example, batteries and that sort of flexible assets in the grid for their own use, not for other users. Also, well, the rooftop PVs, batteries and electrical vehicles. That is quite interesting thing for the DSOs. Also, the digitalization, this decentralization is quite related with the digitalization, with the integration of the smart meters from some time ago, and now the IoT devices, the advanced beam monitoring, and one of the most important things, the digital platforms. The digital platforms not only is used from the side of the DSO, they need this digital platform to communicate to the other levels of the markets and other participants in it. And also in the last present years, one thing that we as DSOs never have, that is the consumer participation through the digital platforms, the energy communities, also deliver demand response and distributed flexibility services. So for me, this is a key point because nowadays, at least on Spain, the DSO, they really don't know how to communicate with this customer, how they can integrate this customer in the day-to-day operation of the grid. But for me, this has a major drawback that, okay, we digitalize the grid, we integrate these users, we integrate the platform, but this also exposes to a really severe cybersecurity risk. Later, I will show you how all these things interconnect, and maybe I can exposure you my idea. But we are growing depending on digital infrastructures. So just to mention what is this flexibility that always I'm talking. So the demand-side flexibility that may shift the consumption of the user, the generation flexibility we can control, and what we want to control, the containment of the energy production, for example, from the PV panels. Also, we want to storage flexibility, use of these batteries, not only from the DSO level, also from the energy community level, just to integrate it in the control and in the resilience of the whole grid. And also one of the major points and one of these new actors in the energy flexibility is the aggregators that they coordinate multiple distributed flexible resources in the grid at the user level, just to provide to the DSO that kind of flexibility. And how this affects to how this affects to the DSO. So yeah, we want to integrate the flexibility in our day-to-day operation and also in our investment plans for the future. Why? Because we can treat with flexibility the voltage deviation, the local congestions, the reverse power flows, and the peak demand situations that few years ago we don't have any idea of how for example, our voltage grid is working, because we don't have any digital solution deploying on that. And with that digital deployment of measurements and insights and so on, we start seeing right now those voltage deviations and those critical problems. And we think that flexibility can provide a more efficient operational solution related with the investment deferral. We prefer to use the flexibility instead of forcing the network through infrastructure upgrades like new transformers, new lines, those sort of things. But all of this needs to be coordinated somehow. And when we talk about flexibility, we usually be on this level, mostly on this one, that is the physical assets and as its own. But for the DSO, when we want as DSO to manage those flexibility, to manage those resources, it's not a direct connection with the resource, because we will need a full market to coordinate those things. So there are different agents, different digital platforms, a market operator, and so on. So just bottom up, as you can see, well, there are not all, but we can consider as independent flexible agents. The batteries integrated in the grid, PV generation, the energy communities, also the large EV scale points of charging, and so on. All of this needs to be coordinated, first of all, from the DSO side, regarding all the data that we need to consume and that we need to collect from these users. First, First, to know how they can provide flexibility to our grids, and also for us to know how we can address flexibility in, for example, 24-hour range for tomorrow. If I will detect congestion in the grid for tomorrow, I will need to know which of these or what kind of flexibility I will need to address these problems. Also, well, this is the system of the DSO, and also we will need to communicate all of this information for two different endpoints: the centralized information system, and also that connects also as real-time connection with the physical assets, and to the market operator. This market operator, we will receive all our orders, all our necessities, just to making those with the offers that making by the different flexible assets. They can provide those solutions straightforward to the market, or they can be go to the market through an aggregator. Also, the DSO we will need what are we doing in the grid before we doing it, because they also have their own plans, their own programming procedures for the next day, for the future, 1 or 5 years in advance. I mean, this is a really high visualization of the market, of the local flexibility markets. But what I want to exposure here is all of these data connection, all of these information connections, transport of data, each one of the agents of the market will have its own system, its own vulnerabilities in this whole picture. So each one of the roles can be attacked, can be a point of attack of cybersecurity. Each one of the platform, the platform from the DSO, also the decentralized information system. We don't want to receive, or we don't want to be attacked, for example, in the point of we receive data from the energy communities, because we can receive wrong measurements. Is a kind of attack. We receive wrong measurements. We will expect something for tomorrow that I will place an offer, a necessity on the market, maybe. And this whole thing, if it is wrong measurements, it can deliver in a payment from the energy community that is not the expected thing. So the grid can be shut down, for example. This can be an attack. And also we can be disconnected from the market or from the decentralized information system in some critical point during the operation of the flexibility or something like that. So we are pretty concerned in the security of this whole system. From European Union, we have, I think it's called NIS2, is one of the pillars of cybersecurity definition for distributed energy operators, also for the DSOs, that makes the basis of the necessities of the communication, the necessities of communicate the errors and the faults and the attacks on our systems. Right now, this is not deployed in Spain, but for example, from the EFI and also from Cuerva, we are participating in some innovation projects, just defining all of this as a sandbox. For example, we will have the opportunity to prove all this connection, all of this market in real time, in real infrastructure. So maybe in a few years, I will have something more to comment, I hope. And what is the role of specific energy communities in this market and in the resilience of the grid? For me, it's 4 major points, and will be active contributors to our system resilience. First of all, is the operational redundancy. that also as we want to operate some way the energy community, but also the energy community as itself has his operational capabilities. This case, they can be disconnected from the grid, so in some occasions, and also that is a layer of security for supply the users of the energy community. Also, the local response capability, they can act locally and quickly from if they are disconnected from the grid or from the major system. They have faster response time due to its own generation. Also, the decentralized decision making, they can act as its own in a hazard environment, and those things reduce the resilience, the reliance on the central control system, and also this central control system is for the energy communities is not a real problem. For other assets as standalone batteries, PV systems, and also the EV charging infrastructures can be a problem, but these centralized systems, for example, are more vulnerable for system-wide cyber disruptions. In the case of the energy communities, they are modular. They have multiple operational nodes, and also increase the system robustness in the area of the energy community, and also the system restoration. In the worst case, they can shut down the whole grid, or for example, for a medium-sized or a small-sized distributor system. So the energy communities can assist in their own restoration processes as local generation support, as they have, in some cases, they have batteries, so they can be in a sliding mode, and also the gradual grid reconnection has lower impacts in those places that we have, for example, local generation. So just as final comment, right now and in mid-term, there are not a lot of flexible energy resources connected to this whole system, to the DSO, to aggregators, to the market, and so on. But we think in long term, a lot of people, a lot of industries, large high power industries, large generations, and so on, will be connected to this system. And in that point, it's a problem, because if you can create an imbalance in the grid, as the last year occurred in Spain, you can black out a whole system if you allow this kind of attacks. And I know flexibility does not replace cybersecurity mechanisms, but improves the operational resilience of our grid. And that's all from my side.
Thank you very much, Pablo.
Thank you.
Okay, so now we have some time for questions. If you have any questions, otherwise I do have.
Any questions in the chat? Sí.
Ay, qué caos.
Thank you.
Accident.
Yes, no, yes. So these are the questions, right? Okay. So we have a question from Esteban for Cristina. Esteban, who is right in front of you, asked you why did you choose Barbara OS for the edge device?
Well, because we are working in some projects and we are working with Barbara. So that's the reason. Yeah, they are partner.
Thank you. And Esteban has other questions. Are the houses and buildings set for the town hall only consumers, or are they also consumers?
Well, they are consumers, but they have a portion of the PV installation. So they are also producing, but they are consumers.
They consumed by the city hall PV.
The production is also decentralized, or it's all concentrated in the town hall?
It's all on the.
We have another question from our colleague Pachalis from Third, who is right here. It's about non-intrusive load monitoring. Which are the appliances you include, you consider?
Okay, we have included the most consumer appliance. For example, the fridge, the washing machine, the oven, and depend on the user appliances.
In terms of conditioning unit,
Probably yes. I'm not sure about all the appliances, but depend on the user appliances. Most of the users has a traditional climate form, such as chimney. So depend on the appliances of the users, but the bigger consumer.
You developing the non-intrusive monitoring algorithms yourself, or are you
No.
commercial solution?
Well, it's not a commercial solution. It's also for other partners.
Does it work well? Because I started working in this non-intrusive monitoring back in 2010, and it didn't work very well.
It's very difficult. For example, the fridge is very it's very easy to know how it's working, because the fridge always works like that. So it's very easy. So yeah, but there are some appliances that are confusing. But we are right now working with our partner in this NIL. So we don't really have the final results of the models.
Thank you, Cristina. We have more questions here. Amadi, for presentation one, also for Cristina, in layer 4, you introduce a flexibility market. Is this type of market currently permitted under Spanish regulation? And how does the regulation situation compare with other EU countries? Is this flexibility market concept intended only for local energy communities, or also can be operated at other levels of the electricity system?
I think that questions my colleague Paulo can
Because
resolve that.
Right now, local flexibility markets are operating in Spain. They are not allowed. We are working on that as a country level. We have different projects. We are present in one of them. Regulation is moving right now in those directions. We have a new kind of market right now, just to introduce flexibility, but it's at high voltage level and at ESO level, not at local services. We expect, like in 2-3 years, maybe we can start to have some kind of review regulation, final regulation to this market, because they will be in Spain. We hope in a time horizon like 2 to 5 years, maybe, because we are right now, they also are working on those centralized platforms. They are integrating DSOs on those platforms. They are connected to other assets, and they are preparing all the technology-based market. So it's okay. And I don't know, the second part of the question is.
Flexibility market is only for energy communities or also available for other levels?
Yeah, no, it's not only, it will be not only available for for energy communities. Also, you as user, as consumer, you have power enough to participate on the market. Like it's not too high, it's like 100 kilowatts. Above that, you can participate on the market. You will be able to participate as your own on the market or through an energy aggregator. And if you can move your power, your active power, you increase your consumption or you reduce your consumption, you can participate. It's not only for energy communities.
Great, thank you, Pablo. We have more questions for layer 5. How do you determine the most appropriate objective function for the optimization problem?
Okay, I'm gonna answer this one and
You can go one by one.
Yeah. Okay, the appropriate objective function is determined by our assets. For example, the optimization model uses the battery charge and discharge signals, the air conditioning signals and actuators, and also, the temperature indoor. They use the temperature indoor so they can optimize the air conditioning signals, also the battery and the price of the energy. So that's the function. Depend on the signals, they will have result, optimization result. I think I'm not sure if I'm answering the question, but
If we can move to next one, and if there is still doubts regarding this question, I encourage them.
Yeah, it's not helpful. So generally, you want to operate all of these devices to do a specific. Who's deciding on this object?
who?
Like the committee deciding that, let's say, minimize CO2 emission or cost,
Okay,
or a specific device do that, or the DSO do that?
okay. It's some optimization model implemented in the edge node, so it's automatic.
So it's local.
Yes, it's local. It's just for the Tom Ford.
In the local node, deciding locally, how does it help the high?
Can you repeat? Sorry.
So at the edge, you have the device which decide locally to do whatever they want to do.
Yeah.
And then, let's say, medium voltage level at the DSO level, is that going to help them? Or
No.
it's going to make the situation even worse?
Well, I'm not sure if I'm getting the question, but the first part, yes, we have a edge node locally that decide the best option to optimize this energy. The idea is to take the signals and to control the air conditioning system. So we can optimize automatically the signals,
Yeah.
the temperature indoor, the price of the energy, and the battery status.
So the question is, if it's based on, let's say, the price of energy, if the energy is less than 2 p.m., everyone wants to use more energy at that time. So it means that I can peak. So make a situation worse in the DSO level. Is that going to help them or make the situation worse?
I'm not sure if we are not developing this model. That's the reason. I mean, everything affects, as you said. So, but well, the model is just working on the morning hours. It's a building, and they are working just. So at night they are not gonna put on the air conditioning system.
Thank you, Cristina. Thank you, Ahmed. You also have a general question, right?
Yeah.
Regarding how resilient architecture is to future regulatory changes. I don't know if Cristina or Pablo. Next question.
In this case, I think it's.
Yep.
But since regulation is not ready yet, next phase will be. And probably you need to rethink about your architecture based on the rule and regulation.
We are developing the architecture just based on their own regulatory the regulatory changes that they are coming like 2 or 3 times a year. We will need to adapt to those regulations. So it's like.
And if you suggest the regulatory teams, what they can do for you that make your life easier.
A lot of things.
I mean, there is no rule or regulation now, and you told us that there will be more in next 2 years.
Yeah,
How they can help you to make this rule and regulation easier?
Right now, it depends if you are looking to the European regulation or the national regulation here in Spain. I mean, from European side, it's quite clear all the things they usually promote those changes in the different countries at its own rate, each one. But here in Spain, for example, in the case of the flexibility markets, they will need to be coordinated with actual markets. And the actual markets are changing a lot in the last few years. Also from the last year, the shutdown, the shut of the whole electricity promote a lot of changes, and those changes are in the top of other changes, and they are creating a lot of national regulation that will be that indirectly affects to the flexible regulation. So, as my understanding, it's like there are too many markets right now, actual markets.
So
Okay.
basically, it's just to make
Things more clear. I mean, we have a lot of regulation, more than needed. I mean, they need to simplify a little bit the whole processes and the requirement for the DSO, for the market operator, and so on. I think they need to simplify all those information transactions and so on. All people wants to know what is happening in the grid all time. Maybe it's not necessary. I don't know if I answered your question, but.
Thank you.
Just small comment from Theo, from DNV, or Dutch partner in eFORT. And he also added, according to that, the optimizer, if all the optimizer behave the same, it will create a large problems, he says. And also they have a Dutch R&D project to look at the integration of smart algorithms in the grid, and the results are public, but in Dutch. And yes, he says that you can relatively easy get the grid down. So maybe we can share that report, and we can have a look at it. Possible now it's easy to translate Dutch to English, so or even Spanish. Yes, that's more comment from there.
Thank you, Theo. And they also have a question regarding the mechanisms behind demand response, which I guess you also mentioned it in your presentation, Cristina, and he's asking if you are using bidding or any other mechanism?
Well,
Strategy or the
well, I cannot respond this question because I'm in charge of all the IoT devices and how it's related with the building and energy community. But I think the demand response, the mechanism behind of the demand response is this one. I mean, is the optimization model. So the result of the optimization model can improve this peak demand or not.
next question for Nazaret. Any direct remote control actions allowed to the users to the assets? Is it allowed via the app, perhaps allowing to hit the pre-cooling, for instance?
Sorry. Well, I think I can respond this one. The remote control actions are automatic. They are not. They cannot control the air conditioning from the town hall with their phones. So it's automatic.
So through the app, there are just one activity.
Yes. Yes.
Thank you. The next one is also for Nazaret. Do you know if there is any help, monetary or material from the government for the users to adopt applications like yours?
More than the government, I think that we have a problem with the data. For example, we take the data for the application from DataDis, that is a Spanish application where all the DSO put the data. But we have so many problems because they are not good data. So sometimes we have like an open space data and the users cannot see it. And that makes that the application in the end sometimes is not the best, and the users complain about it because they cannot see what they consume they have. They can see the generation, but not the consume. So for trying to have better data, that maybe is where we find the digitalization and everything. I think that is a problem for the app. Because now also we have some rules. For example, in Spain we have 2 kilometers of radius, and now they are trying to make a bigger 5 kilometers. That will be very good, but we are more than 1 or 2 years trying to approve this place role. So these kind of things we can make the energy community scale faster, I think.
For that reason, we have installed in that community in Furnace smart meters to increase the data collection, so the users can watch their consumption.
In Furnace, we are trying with the smart meter, and if this is working, we will do it with all the other users. Even the users, when we ask them what would you need for the experience good, they say real-time data because they want to see the data when they, for example, go down the wash machine, see what is the production and the generation, and we have this lack of data now, and it's difficult because you have to install the smart meter, go to the house, and then in the house they use the Wi-Fi, and sometimes it's bad. So in the end, the infrastructure and the service can be difficult with the data is the most important, I think, for give a good service. Yes.
And knowledge from the data. That is. So as you said, we have installed smart meters with Wi-Fi connection. We are right now proving or testing narrowband IoT smart meters because we have cobertura. Coverage in the town, and we have the range. So we are right now proving other communication channels to improve this problem.
Thank you. Yes, let's have some time for a few more questions. This is for Pablo. Any communication between aggregator and DSOs? Is it not required? DSOs are informed via the centralized information system.
Right now, as this planteado,
Set?
yeah, right now, as said, it's not direct communication between the DSO and the aggregator. It's doing through the centralized platform. But maybe in the future, there are other type of flexible market. No, it's not a market. It's, for example, the flexible connections. That is a direct contract between the DSO and the user can do it through an aggregator. So in that specific so will contact and communicate directly with the aggregator. Right now, it's not that communication allowed or in the future because the DSO must be separate from the aggregator to make a trusty market. I mean, we will deploy there our necessities. The aggregator will deploy in the market our log aggregating the grid, but the DSO cannot know which specific user will deploy the flexibility because to not allow certain kind of I don't know, corruption. Maybe it's like, okay, you will resolve all my problems as a user. I will pay you for that, but I only want to pay you, not your neighborhood. So just to prevent those kind of situations and make that trustworthy market. Right now, it's going to be separate the applications from the DSO and the aggregator.
Follow-up question, one. How fast is the real-time information?
Okay. Okay. It will depend a lot on the type of advanced method in the grid, because, for example, the smart meters in most of occasions, the granularity of the data is like 1 hour. It depends on the information that you are getting, but for example, for energy is 1 hour. And you usually receive that information once a day. But if you are a consumer with more than 50 kilowatts of consumption, it will go down to 15 minutes. And you will receive those measurements 15 minutes. It will depend a lot on the type of user, the type of technology that you are using, your own data processes, if you are using an FTP or other kind of things, and yeah, and your own system, data system. But for the participation in local markets, maybe we need to go down to 15 minutes. Obligatory.
Thank you. We are running out of time. Aleida, do we have time for a few more questions? So, Theo has another one for you, Pablo. Is the DSO in Spain willing to pay for local flexibility? And are these payments ending up in the end users?
Yeah, sure. We want to pay for that flexibility. We want to pay to the user because we think and we know, we have our studies that it will depend a lot on the price of flexibility. Yeah, it's true. But for us as DSO, it's more efficient to pay for the flexibility instead of instead of installing new infrastructure. Because maybe you will be or you are when you deploy this kind of infrastructure, maybe it's only to overcome a problem of 10 hours a year. During 10 hours a year, I have a problem of congestion in my grid. Okay, to solve those problems, maybe I need to invest like $5 million, 5 million euros, just to provide a new transformer, a new line, a new connection, or something like that, instead of paying for the flexibility of those 10 hours. That maybe it's supposed to mean like 5,000 euros a year, maybe, I don't know, it will depend on the level, so on. So yeah, the DSO will pay to the user, but also DSO will set the top price that they want to pay for those flexibility. Yes, it's based on our studies. Like, okay, it's interesting for me if I pay, I don't know, 150 euros per kilowatt, per kilowatt or per megawatt or whatever. But yeah.
And Theo has a follow-up question. If the end consumer invests in flexibility, how do they know that the DSO will not force the grid and that the investment boosts their value?
Yeah.
Is it like a yes, issue, right?
Yeah, from the user side, maybe it's not the best for you to just invest only to participate in flexibility markets. It's not the flexibility markets are not meant to be in that way. It's the other way around. You have some assets, you invest in a battery in the industry because you expect to reduce your energy expenditure like 30%. Okay. Maybe it's interesting for you to participate in the local flexibility market like once a month for 2 hours. If you don't want to use for 2 hours, in those 2 hours a month, your battery, maybe you can participate in the flexibility market. But it's not meant to be like, I have an industry, I will place a battery only to participate in the flexibility markets. It's like complement. It's like a complement on your energy reduction strategy.
Okay, thank you, Pablo. And I don't know, this is the last one from Esteban, or do we have more questions?
Okay, we move it.
We have new publications here.
I think it's not up there.
Next question is mine.
Is yours.
Probably, Pablo, it has been answered before, talking about communication between aggregator and DSO and the dedicated controls. And at that time, I was wondering, we have seen a lot of infrastructure, a lot of sensors down to the very level of the consumers. And I was just wondering if energy communities need to be integrated with the distribution systems in terms of communication that has changed, or as you can see, I don't know if it will be more integrated or more through the control centers. How that question.
Yeah, I think if the energy community wants to participate in the flexibility market, for sure they will need a point of communication with the market. I mean, they can do it through an aggregator, they can do it as its own. But first of all, you need a point of communication with the market that is maybe can be the solar production and so on. But also the other way around, the market will need a point of communication with the energy community just to for control. They will need to get access to the control of the energy community. I mean, maybe to do advertisement or something like that. But the DSO as itself in the flexibility market will not connect directly to the energy community. Instead, you have a flexible contract. That is, the market operator goes out of those contracts and is a direct contract between the DSO and the energy community. In that way, I will need to connect to the system.
So the control commands are directly issued by the DSO to the community.
Yeah, in flexible contract, yeah.
Thank you, Pablo. Jesus, we have another one from Baman, so
So maybe I can just-
please go ahead. Yeah.
In one of the slides, in the last ones, there's a word can, for instance, can help restoration, gigamitis. Do you have any proof that this really helps?
Maybe like you can look to the microgrids, other microgrids. If you have a battery with the capability of grid forming, those you will create a reference for the electricity to reconnect other systems. I mean, you don't need to wait maybe for the whole restoration of the grid, that you can start restoring the grid from the energy community. It is true that you will need a lot of power to restore, but for example, in a low voltage grid with certain users, you have a blackout in the grid, you isolate through the transformer, the medium to low voltage transformer, you isolate that low voltage grid and can provide energy to those grid from the energy community and the systems of the energy community. But I mean, this is a special case because you will need a lot of power. Maybe you can find them in an energy community, but in the like in industrial area.
So is this still on paper, or have you seen such a thing in the previous blackout in Spain?
We have in other projects that I participate in the past, we tried to prove this, but right now I didn't know the result. But yeah, we study this and we make our simulations, but it's a really special case. It's like this is like looking forward in the time. Like today is quite strange, but
Okay, thanks.
Thank you. Okay, so many questions do we have left? I think that this is the last one from Christian. When you talk about optimizing the system based on the battery, to pose the question yourself, Christian. So this is yours.
Yeah.
So please go ahead.
Yeah, I was wondering if you are managing the energy flux of inverter some way, or you just suggest the
The idea is to make some suggestions, but also to act in the public buildings, how controlling the air conditioning systems. So the end of the optimization is to turn on or turn off the splits.
Yes.
Or charge the battery when the price of the energy is high, low.
Yeah, but to discharge battery or charge battery, you need to control it better. No?
Yes.
So do you think some way to do it? Because commercial inverter is like a black box. You can do nothing on that.
We are collecting data on all of these assets, uncentralized in the edge node. In the edge node, it's implemented, or we are going to implement this optimization. But we are collecting all this data from the assets.
Thank you.
Thank you. I think this is the last one, right? So Thank you so much for the great presentations, and thank you very much for the questions.